Hey guys, Mr. Backerberg here. In this video, we're going to look at other applications of systems of equations and matrices. So in this first example, we're going to look at fitting a parabola to 3 points. So we want to determine the equation for a parabola that passes through the points -1, 5, 2, -1, and 3, 13. So what we have to remember is the general form of a quadratic equation, and that looks like y equals ax squared plus bx plus c. And what we're going to do is we're going to build a system of equations using these 3 points and that general form of a quadratic equation to then go through and solve to figure out what our a, our b, and our c values are. So what I'm going to do with this first point is I'm going to plug in that x and that y value to this general form of our quadratic, and that's going to give me one of my equations for my system. So I plug in the 5 on the left-hand side equals a times -1 squared plus b times -1 plus c. Now we can do a little bit of cleanup work with this. When we square that -1, that turns into a +1. So when we multiply that by the a, that just becomes an a. Then when we take that b times that -1, that becomes a -b plus c. So this is going to be the first equation. Now typically we like to have our answers on the right hand side, so I am going to rearrange that down here, and I'm going to write it as a minus b plus c equals 5. Now my second equation, I'm going to use that x value of 2 and that y value of -1. So we're going to get -1 equals a times 2 squared plus b times 2 plus c. 2 squared is 4, so we get -1 equals 4a plus 2 times b is 2b plus c. And again, I like to have my answer on the right-hand side, so I'm going to flip-flop that equation. So we get 4a plus 2b plus c equals -1. And then for our last equation, we need to plug in the 3 for our x and the 13 for our y. So we get 13 equals a times 3 squared plus b times 3 plus c. So we get 13 equals 3 squared is 9, so we get 9a plus 3b plus c. And I'm going to put that 13 on the right-hand side. So we get 9a plus 3b plus c equals 13. Now our goal is to solve to figure out what our a, b, and our c values are. Now what I'm going to do is take this and turn this into some matrices, and I'm going to look at a coefficient matrix, so looking at the numbers in front of the variables. So in my first equation, in front of that a we've got a 1, in front of that b we've got a -1, and in front of that c we've got a +1. In my second equation, I've got a 4 in front of that a 2 in front of the b, and a 1 in front of the c. And in my last equation, I've got a 9 in front of the a 3 in front of the b, and a 1 in front of the c. Then I'm going to take our variable matrix, and normally we would have x, y, and z in here, but here we're dealing with variables a, b, and c, equals our answers. We have 5, -1, and 13. So this is my A matrix, this is my X matrix, and this is my B. So remember, to solve to get X, we want to do the inverse of A times B, and I'm going to do that on my calculator. So the first thing we need to do is edit our matrices. So I'm going to go second matrix, and I'm going to edit matrix A. This is a 3 by 3 matrix, and I'm going to get those entries filled in. And then I'm going to need to edit matrix B, so second matrix, edit matrix B. This is a 3 by 1 matrix, and I'm going to fill in those entries. So now we've got our 2 matrices filled in, so we need to take matrix A, do its inverse, and multiply that by matrix B. And we should get this matrix. Remember, that top value is our A value, that middle value is our B, and that bottom value is our C. So as we just saw, our A value was 4, our B value was -6, and our C value was -5. So I want to take those A, B, and C values and plug them into this general form of our quadratic. So we should get y equals 4x squared minus 6x minus 5. So this quadratic equation will produce a graph that goes through those 3 points that I gave you in the description for this problem. Now in this example, we're going to be mixing some solutions. So Alex's drugstore needs to prepare a 60-liter mixture that is 40% acid, and they have 3 different concentrations of acid on hand. The first concentration is 15% acid, the second concentration is 35% acid, and the third concentration is 55% acid. Because of what they have on hand, they need to use twice as much of the 35% solution as they do of the 55% solution. So we want to go ahead and figure out how much of each solution they need to use. Now there's a lot of information presented to us, but we're going to try to take all of this and turn it into a system of equations so that we can then go through and solve it. So the first thing we know is that we've got 3 different concentrations of solution, and I'm going to use a different variable to represent our amount that we're going to use for each solution. So I'm going to use x to represent the amount that we're using at 15%. I'm going to use y to represent the amount that we're using at 35%, and I'm going to use z to represent our 55% amount. So my first equation, when I add those 3 amounts together, so when I add those x, y, and z values together, we're supposed to get a 60-liter solution. Now for the second part, I want to deal with those concentrations, those percentages, but I want to turn them into a decimal. And what that's going to do is tell us how much pure acid we have total. So if I take the 0.15 times that x amount, plus the 0.35 times that y amount, plus that 0.55 times our z amount. Now it doesn't tell us how many liters of pure acid we have, but we can figure that out. We've got a 60-liter solution that is 40% acid, so I can do a little multiplying in there. If I take 0.4, which is 40%, times that 60-liter solution, that's going to tell us that we have 24 liters of pure acid. So here, where we're looking at the amount of acid that we've got, we want to use that 24. Now, the last thing we're told is that we need to use twice as much of the 35% solution as we do of our 55% solution. So our 35% solution was our y value, and our 55% solution was our z value. So if we're doing twice as much of the 35% as the 55%, then what we've got in there is our y value, which is the 35%, is twice as much as the z value. Now with these equations, we've got all of our variables on the left-hand side, which is why I wrote this one off to the side, because what I want to do is get my y and z values on the same side. So I'm going to subtract that 2z over. So then that's going to give me the equation y minus 2z equals 0. Now I'm going to take this system of equations and turn it into some matrices so that I can use my calculator to help me solve this. So my coefficient matrix is going to look like 1, 1, 1, 0.15, 0.35, and 0.55, and then 0, 1, negative 2. In our variable matrix, we've got x, y, and z. And then in our answer matrix, we've got 60, 24, and 0. So this is our A matrix, this is our X matrix, and this is our B matrix. Remember, to solve to get X, we want to do the inverse of A times B. And I'm going to use my calculator to help me out there. So the first thing we need to do in our calculator is edit matrix A. That's going to be a 3 by 3 matrix, and we're going to fill in those entries from our matrix that we just saw. So those are our entries from our coefficient matrix. And then we're going to need to edit our matrix B. And that's going to be a 3 by 1 matrix. And I'm going to fill in those entries that we had. So then I'll quit out of here. I'll take matrix A, do its inverse, times matrix B. And we're going to get this answer in here. So this is the amount of that first solution that we need to use, this is the amount of that second solution that we need to use, and this is the amount of that third solution that we need to use. So that just told us that we need to use 3.75 liters of our 15% solution. We need to use 37.5 liters of our 35% solution and 18.75 liters of our 55% solution. That's going to be it for this video. Thanks for watching.